I think when we first envisioned 3D Sim, we envisioned it as a way of helping the 3D printing or additive manufacturing industry become what it has the potential to be.
.3DSim is an amazing company to start with. We are a group of researchers who are world-class, a group of seasoned software professionals, and a group of business leaders, all coming together for a singular purpose to create this great software package we're working on. We really focus on excellence. We want to put people in a position where they can truly excel at what they do.
So when we founded 3D Sim, we said, well, we have a lot of insight. We've got software we're developing that can help us to get products to market faster. So our goal is to help customers, our customers being the users of our software, develop real physical parts and get them into industry, into a jet engine, into somebody's body as an implant more quickly. And so we're providing that scientific insight using software that would otherwise take them millions of dollars of research and development and experiments to get that insight. So we're trying to replace experimental insight with scientific insight through software.
Inherent in the process today, there's a lot of trial and error that goes on in building parts. It really takes a lot of expertise to put in the right support structures to make sure the build doesn't fail. Build failures are highly costly. It's machine time, it's people time, it's material cost. And so one thing that the 3D Sim software will do is help build the part right the first time. Because of the simulation nature of the product, we can put in support structures that counteract all the physical phenomena that happen during the build process.
And what happened is we started building up this tool set of a whole bunch of useful mathematical algorithms that made prediction of additive manufacturing phenomena possible. But the core bottleneck always in simulation of additive manufacturing is we have to predict trillions of things going on and it just takes too long to do all those calculations. So our focus had always been, can we make a simulation fast enough to get useful information within hours to days at the most, and maybe even minutes back to the user. Whereas today, even today, all of our competitors are taking days or weeks or months to calculate something useful. Our idea is we want to calculate something useful faster than you can experimentally get insight. That way they will choose to do a simulation not only for cost reasons, but also for time reasons. So if you can run an experiment faster than you can do a simulation, then you're just going to run the experiment because you're saving time, and time is usually money. So if we can flip that over and do the simulation faster than the experiment, now we throw the entire innovation cycle on its head.
The value proposition of 3D Sim is to adapt, is to mass customize in the area of simulation, so that if any of the variable in creating a part changes, then we can quickly change and give a reasonable answer to the designer so that he can design his stuff around very quickly and then make a new part which can qualify and certify for their customers as soon as they make the part.
The software is served in a cloud-based environment, which really gives our customers the ability to use the software from virtually any device, anywhere they're connected to the internet. The solver itself is fast. It's very fast, much faster than any of our competitors. And when you put those two together, we really have a unique offering that will help disrupt the AM industry. 3D Sim has two product lines. One is called Exasim. Exasim is solely focused on machine operators and trying to make their lives easier. The core offering in that product is a support optimization tool, which will build a support structure based on the residual stress that we calculate during simulation. Our second product is called Flex, and the focus of Flex is more the scientific user, the researcher, really offering the ability for users to do what-if scenarios across a variety of different properties that can be changed during the simulation process.
And I'm really excited to see how our customers use this. I'm quite confident that if we do our job right, if we give them meaningful, correct predictions quickly, they will then become much more creative in how they use additive manufacturing and 3D printing.